In this episode, we look at 4 recovery metrics that help organizations describe downtime, data loss, repair time, and reliability in a clear way. These terms are Recovery Time Objective, RTO, Recovery Point Objective, RPO, Mean Time to Repair, MTTR, and Mean Time Between Failures, MTBF. They can feel similar at first because they all deal with disruption and recovery, but each one answers a different question. RTO asks how long a system or process can be down before the impact becomes unacceptable. RPO asks how much data loss, measured as time, the organization can tolerate. MTTR asks how long repair usually takes after something fails. MTBF asks how long something usually runs before it fails again. Once you separate the question each metric answers, the topic becomes much easier to understand. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. RTO is about time to restore service. If an important application goes offline, RTO describes the maximum acceptable amount of downtime before the business impact becomes too high. For example, an online ordering system may have a short RTO because every minute of downtime may mean lost sales and frustrated customers. A monthly reporting system may have a longer RTO because it can be unavailable for a while without causing immediate harm. RTO is not the same as how long recovery actually takes. It is the target the organization wants or needs to meet. The recovery design should then be built around that target. If the RTO is very short, the organization may need high availability, automated failover, replicated systems, and strong monitoring. If the RTO is longer, a slower manual recovery process may be acceptable. RPO is about how much data the organization can afford to lose. It is measured backward in time from the moment of disruption. If a system fails at noon, and the most recent usable backup is from 11 in the morning, the organization may lose up to 1 hour of data. In that case, the recovery point is 1 hour before the failure. A short RPO means the organization needs very frequent backups, replication, journaling, or another method that preserves recent changes. A longer RPO means the organization can tolerate losing more recent data. Think of RTO as asking how long until the service is back, while RPO asks how far back in time the recovered data can be. These two metrics are related, but they are not interchangeable. One focuses on downtime. The other focuses on data loss. You can use a simple banking example to separate RTO and RPO. Imagine a payment system that processes transactions all day. If the system goes down, the organization may need it back quickly because customers and business partners rely on it. That is an RTO concern. If transactions were processed during the last few minutes before the outage, the organization also needs to know whether those transactions can be recovered. That is an RPO concern. A system could return to service quickly but still lose recent transactions if data protection was weak. Another system could preserve nearly all data but take too long to restore if recovery procedures are slow. Both outcomes can be unacceptable depending on the business. This is why recovery planning uses both metrics. The organization needs to know how quickly service must return and how much recent data can be lost. MTTR is about repair time after a failure occurs. It looks at the average amount of time needed to diagnose, fix, restore, or return a failed component or service to working condition. The exact wording can vary slightly in different environments, but for security plus thinking, MTTR is commonly tied to how long it takes to recover or repair after something breaks. If a server fails and the team usually needs 2 hours to replace the failed part, restore the service, and confirm normal operation, that contributes to MTTR. A lower MTTR is usually better because it means failures are repaired faster. Organizations can reduce MTTR with good monitoring, spare parts, clear procedures, trained staff, automation, vendor support, and tested recovery steps. MTTR is not a goal like RTO. It is more of an observed or expected repair performance measure. MTBF is about reliability over time. It estimates the average time a component or system operates before failing. If a device has a high MTBF, it is expected to run longer between failures. If it has a low MTBF, failures are expected more often. This metric is useful when organizations evaluate hardware, storage devices, network equipment, or other components where reliability matters. MTBF does not guarantee that a specific device will last for that exact amount of time. It is an average or expectation, not a promise. A device with a strong MTBF can still fail early, and a weaker device can sometimes last longer than expected. For security and operations, MTBF helps with planning maintenance, spare capacity, lifecycle replacement, and resilience design. It tells you something about how often failure may happen, not how fast repair will be. A useful way to compare MTTR and MTBF is to ask whether the metric is looking after a failure or before the next one. MTTR starts after something has gone wrong and asks how long repair takes. MTBF looks at the operating period between failures and asks how reliable the system is over time. If a network switch fails every few months but can be replaced in 15 minutes, it may have a lower MTBF but a low MTTR. If a storage system rarely fails but takes many hours to repair when it does, it may have a high MTBF but a high MTTR. You need both ideas because reliability and repair speed are different. A system that fails rarely is helpful. A system that can be repaired quickly is also helpful. The strongest environments usually care about both. These metrics connect directly to business impact. A technical team may be able to describe systems in terms of servers, databases, storage, network paths, and backups, but leaders usually need to understand what disruption means for the organization. RTO and RPO help translate recovery expectations into business language. How long can the payroll system be down? How much order data can be lost? How quickly must identity services return? How much data can the organization recreate manually if needed? MTTR and MTBF help translate operational reliability into planning terms. How often does a component usually fail? How long does repair usually take? These answers influence budgets, staffing, architecture, vendor choices, and testing. Without metrics, recovery expectations may stay vague. With metrics, the organization can have clearer conversations about cost, risk, and acceptable interruption. There is often a trade-off between stricter recovery metrics and cost. A very short RTO usually requires more investment because the organization needs systems that are already running or can take over quickly. That may mean hot sites, clustering, load balancing, automated failover, replicated databases, and constant monitoring. A very short RPO also costs more because data must be captured or replicated more frequently. That may require continuous replication, transaction logs, or more advanced backup designs. Lower MTTR may require better tools, staffing, automation, spare equipment, and vendor support agreements. Higher MTBF may require more reliable hardware, better design, preventive maintenance, or replacement of aging systems. These investments may be justified for critical services, but not every system needs the most expensive recovery capability. Good planning matches the metric to the real business need. Recovery metrics also help set priorities. During a major incident, not every system can always be restored at the same time. Identity services, core networks, payment platforms, emergency communications, and customer-facing systems may have shorter RTO values than low-priority internal tools. Systems with short RPO values may need data protection methods that capture changes frequently. Less critical systems may be restored later or from older backups. This prioritization matters because technical resources are limited during a disruption. People may be tired, systems may be damaged, vendors may be busy, and information may be incomplete. Metrics help reduce argument and confusion by showing which services must come first. They also reveal dependencies. A system with a short RTO may depend on another system that also needs a short RTO. If the dependency is ignored, the recovery plan may fail even when the main system looks prioritized. One common misunderstanding is treating RTO as a guarantee. If a business says the RTO is 1 hour, that does not mean recovery will magically happen in 1 hour. It means the recovery plan should be designed, funded, staffed, and tested to meet that target. If the current process takes 6 hours, then the 1-hour RTO is only a wish until the organization improves the design. Another misunderstanding is assuming RPO means backup frequency by itself. Frequent backups help, but the organization also has to make sure those backups complete successfully, are protected, and can be restored. You may also see confusion between MTTR and RTO. MTTR describes average repair time based on experience or expectation. RTO describes a target for acceptable downtime. They may influence each other, but they are not the same metric. Another common issue is focusing on one metric while ignoring the others. A system may have excellent backup frequency, giving it a short RPO, but if restoration takes too long, the RTO may still be missed. A system may have fast failover, giving it a short RTO, but if replication is delayed or incomplete, recent data may be lost, and the RPO may be missed. A component may be highly reliable with a strong MTBF, but when it finally fails, repair may be slow because the team lacks spare parts or clear procedures. A component may be repaired quickly, but if it fails constantly, users still experience repeated disruption. Resilience is not about one impressive number. It is about understanding how the numbers work together. The organization needs realistic downtime targets, realistic data loss targets, reliable components, and repair processes that can meet the need. Testing is where these metrics become real. A recovery plan may state that a system has an RTO of 2 hours and an RPO of 15 minutes, but a test may show that restoration takes 4 hours and the latest usable backup is 90 minutes old. That test result is valuable because it exposes the gap before a real crisis. The organization can then improve backup frequency, increase replication, redesign failover, tune restoration procedures, add capacity, or adjust the stated business expectation. Testing also helps measure MTTR because it shows how long teams actually take to repair or restore under controlled conditions. Reliability data over time helps refine MTBF expectations. The point is not to create perfect numbers for a document. The point is to learn whether the recovery design can meet the needs that the business has accepted. For Security Plus questions, look for the wording that tells you what the scenario is measuring. If the question asks how long a system can be down before unacceptable impact occurs, choose RTO. If it asks how much data loss is acceptable or how far back in time recovery can go, choose RPO. If it asks how long repair or restoration usually takes after failure, choose MTTR. If it asks how long a system or component usually operates before failing, choose MTBF. If a scenario says the organization needs to restore service within 4 hours, that is RTO. If it says the organization can lose no more than 15 minutes of transactions, that is RPO. If it describes reducing the average repair time, that is MTTR. If it describes improving reliability so failures happen less often, that is MTBF. The larger lesson is that recovery metrics give clear language to disruption, data loss, repair, and reliability. RTO tells you the acceptable downtime target. RPO tells you the acceptable data loss target. MTTR tells you how long repair or restoration usually takes after failure. MTBF tells you how long a component or system usually runs before failing again. These metrics help organizations design backup strategies, choose recovery sites, plan failover, set priorities, justify budgets, and test whether recovery plans are realistic. They also help you avoid vague thinking. Instead of saying a system should recover quickly, you can ask how quickly. Instead of saying data loss should be small, you can ask how much loss is acceptable. That precision is what makes recovery planning useful, and it is exactly the kind of distinction Security Plus expects you to recognize.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.